Hello everyone, and welcome to our next pre-lab. In this lab, as you can see from the title, we are going to investigate the area of a circle. So we've already done a lab where we figured out the relationship between the circumference and the diameter. Right? Now we're going to look at the relationship between the area, which we will use as a symbol, a capital A, and the radius, right, from the center to the edge. Right, of a circle, which we will use a lowercase r. I've also seen this as a capital R, but usually an R. So the purpose of this lab is to create graphical and mathematical representations of the relationship between the area and the radius of a circle. Right? So we're going to look at a bunch of different circles. We're going to measure the areas and the radius. We're going to graph them. We're going to see what it looks like, and we're going to try to figure out a representation, a relationship, if you will, and then build a math model for that. Right? Similar thing to what we did with a few nuances, as you will see. So sometimes I've had people actually take circular objects and draw around them and figure out the area, but tried to make the lab a little simpler. So I've created a little sheet that you're all going to get that looks just like this one. You'll notice it has 6 different size circles on it. Well, the neat thing about the paper that it's drawn on is that these squares are 1 centimeter a side. So each square is 1 centimeter squared of area. So if I want to know the area of one of these circles, I can basically count the squares. Now, you're going to see, though, that when you go to count the squares, right, you might have some full squares, but then you're going to have a bunch of partial squares. Well, to get the best data, you need to estimate. Right? People that get the best data in this lab will be those that take the time to try to estimate. You know, like, what tenth of one is this? You know, oh, okay, this is 9/10. This maybe is 2/10. Right? And add them all up as you go around. I've seen people write on them. I've seen people list them on a page to help them keep track and then add them up. You know, I've seen people read them off while other people run a calculator. But however you choose to do it, right, you have to count all the full ones as 1 centimeter each, and then all the little pieces around the edge. Right? Estimate to get the best results. To figure out the radius, you simply need to measure the diameter across, you know, count how many of these there are, those are a centimeter apiece, and cut it in half. Right? And you'll have the radius. So measure the diameter. And if you notice here, I tried to make these like perfect. Right? When I made these, I made them have a nice diameter to them. Right? So no fractions there. And all the estimation will come in the area. Okay? And you have 6 different ones of these to do. You'll put them into a data table. Right? Radius in centimeters, area in centimeters squared, right? Each block is a centimeter squared of area. And then eventually you'll make a graph. Now when you get to the graph, of course, remember there is the online help, right? Data analysis with graphical analysis, because you're going to use that same program again to graph this. Right? You want a title, you want to label the axes, you want to put units in. Please make the radius the independent variable, graph it on the horizontal axis. If you think about how I would have made this sheet, right, I made these by making the radii perfect as I could, right? So I chose the radii, right, and then we measure the resulting diameters. Areas. So area is the dependent variable, radius is the independent variable. Right? And you're going to see something a little different than we saw in the circle lab. So this is going to take us, like with the circle lab, a couple of days to work through the nuances of this one. But it's going to be a new relationship that we haven't seen before, but that exists in nature. So I hope you enjoyed our little area of the circle pre-lab.